Welcome to solverfy.
Of the two nuclei. So conservation of energy says the total energy is conserved, where K1 plus E1 is the total initial energy and K2 plus U2 is the total final energy. And we know that the initial potential energy and the final kinetic energy are zero. So this gives K1 to be equal to U2, and we know that K1 is the kinetic energy of the two nuclei, and they have the same mass and the same velocity. So the kinetic energy of each nuclei is going to be same. And U2 is the potential energy which comes from Coulomb's law. So this is equal to Ke square over R. E is basically the charge of the electron and K is the Coulomb constant and is given by this value. This gives velocity to be equal to E times root over of K over mr. So m is given to be this value and E is the charge of the electron. So we are just taking the magnitude here. And this gives the magnitude of velocity to be 8.3 times 10 to the power 6 meter per second. For the second part, we are going to use Newton's law, which says the total force or the net force is equal to mass times acceleration. We have to include the vector sign because this is the vector sum. The net force is given by the vector sum of all the forces. And over here, the net force is Q times V times V. So this is a circle, so the magnitude, when the path is a circle, velocity and magnetic field are perpendicular here. So we don't need to do the cross product explicitly, we can just write it like that. So this is equal to, and here MA is basically the centripetal force because the particle is moving around a circle. So A is the centripetal acceleration, which is given by V square over R. And we are just equating the magnitudes of both sides. This gives the magnitude of magnetic field to be mv over qr. And we solve this using the value of velocity we found over here, and we get this magnetic field to be 0.14 Tesla. Thank you.